Scaling data physicalization. How does size influence experience? This is presented by Irene López García and Eva Hornecker from Bauhaus-Universität Weimar. Data physicalization, the word is analogous to visualization, is defined as physical artifacts whose geometry or material properties encode data. Research sees various benefits: active and multimodal sensory perception. They offer natural 3D stereo vision with perfect depth of field, unlike 3D graphics on a screen or VR. They support spatial cognition, motor memory after interacting with them, and provide affordances for interaction. Physicalizations can be touched, held, handed around, and the ability to touch data has been shown to improve memory of data and to increase engagement. We here show the range of work. In HCI, what's typical are, like what you see in the middle, 3D printed versions of traditional representations, usually handheld size. Artists, on the other hand, often create quite large data representations of an architectural or at least over human size dimension. On the left, you see a walkable data sculpture, where the London crime rates tower over the audience who can walk around this map. On the right, you see a design project where core information is only revealed when you drop these data seeds in how they tumble down. So you need to interact with them, and they're fairly small. So we here see the variety in size for physicalization, as well as a variety of approaches between design, art, and HCI, and if they're meant to be handled. We also see that works from art and design are not aiming to convey accurate numbers as much, but rather to raise curiosity, provide surprise, or to create an emotional connection and impact. These aspects, which I bracket under UX, user experience, so far have been fairly little investigated. In this study, we tackle the question of what the role of scale or size is for the user experience. In particular, we wonder if a larger size may have a larger impact in terms of a more forceful message. Why do we even think that scale plays a role? In the arts and architecture, scale is used intentionally as an expressive design element. And that exploits that scale is always in relation to the observer's body. It's a relational aspect. For instance, we can shrink the viewer to change their relationship to the object, or we can miniaturize the object to invite for a more intimate inspection. And scale is not only in relation to a viewer, but also to the environment. So this is an aspect of situatedness. Neuropsychology tells us that sculptural and architectural objects are perceived and understood in terms of the opportunities for action that they provide. And these opportunities change at different scale. So what's the impact of scale for action and perception? Many benefits of physicalization, such as interaction affordances, haptic memory of prior interaction, apply for a scale that can be physically manipulated and rotated, that is, for handheld sizes. Remember the data seeds. With larger physicalizations, it's the viewer themselves that needs to navigate around the object. So how does this change the experience?
We created two designs for the same underlying dataset and built 3 different scales of each. As data, a list of documented extinct species from Wikipedia was chosen. The last 1,000 years were extracted as data and tabulated as numbers. The timeline was segmented into decades and centuries. The models were used in a 2-part study. First, we enlisted people in public spaces to rate models in a questionnaire. Overall, 85 participants each evaluated one of the objects. Second, private interviews, where participants were shown all 3 sizes of one design and were asked to discuss them. Design A is based on a fairly traditional bar chart timeline of species extinct across time, aggregated into decades. Each decade is represented by a white vertical thread. The gap between the thread and the bottom of the frame represents the number of species extinct. This design uses the emptiness, an image of this broken weave, to represent the reduction in biodiversity and its reversible effects. Design B is less conventional and takes greater advantage of the third dimension. It aggregates data in centuries, each represented by a hoop, so each hoop is like a summary of what happened in a century. They were hanging parallel in chronological order. Each red thread represents one species documented as lost. This design allows each segment to be moved and looked at individually, but also to see the effect in a summative view from the side, as in this large picture here. One then sees the accumulation of extinct species in blood red. Each design was built in 3 different scales, from handheld to almost human-sized. The designs were not meant to be compared directly, but to gain wider insights. Design A was scaled quite faithfully. The threads and the wooden frames used worked well. For Design B, we faced construction issues that translated into bigger differences in appearances. The large version hoops needed to be made of plastic hoops instead of wire for stability, unlike the other 2 versions. The relation between the thread and the hoop was thus noticeably different across models. The models were then set up in different sessions in public spaces, and we enlisted participants on the spot to rate one model version on questionnaires. The first set of questions asked about data understanding and engagement with the topic. The second part contained a short attractive questionnaire and established UX evaluation method. For Design A, people rated the smaller scale the worst in both parts, while the large version scored best. For Design B, answers show no clear pattern. The only consistent thing was that the large version fared worst for this design. Nevertheless, this part of the study allowed us to see how people understood our data physicalizations. For example, it became clear that Design B was easier to understand than A, despite being less conventional. This made us favorite for the interviews in the next step. We conducted 6 semi-structured interviews where participants were shown all 3 scales of one design. From comments, we found that the medium-sized versions of both designs received the most favorable responses. This was usually related to how easy it was to perceive the model as a whole and take in all the information. The large version was often experienced as uncomfortable and hard to take in. They said things like, "You cannot compare it in a whole image," or "It's too big for my eyes." This made it hard to investigate and compare data. The medium size gained praise for being more elegant and clear as well, especially for Design B. The medium size was also pointed at and looked at when participants talked about the data itself. Meanwhile, the smaller versions were deemed unimpressive or harder to understand. Lastly, it was clear that the differences in materials between the 3 versions of Design B influenced participants' responses, which clearly constitutes a limitation of our study. For Design A, the smaller version was barely handled by participants, in contrast with Design B. This could be due to the lack of movable pieces, but also its fragile look, with
One of our first insights was that if we're not just 3D printing something, but using more crafty materials, the material design may not that easily scale. So the details of the material change when we scale up, and this may sometimes simply be due to the availability of materials. But also, physical constructions will often require changes in the construction or in the material when resized to retain stability. So in our case, that was for the loops. And physical forces do not always behave linearly. What works in miniature may need extra trusses or needs to be made much thinner in order to bear its own weight. There's also visual effects of scaling. Something that looks delicate in small size might actually end up looking overloaded and almost brutal in a huge size. So there is a large impact of seemingly small decisions in design. But moreover, there is no best scale. So the smaller physicalizations have the advantage to enable users to physically handle and quickly change perspective by turning the objects around, which might then also appeal to our liking for touch. Also, our participants all said that they were quicker to take in and provided better overview. Pointing or looking at something and then refocusing the eyes on another detail was easy with the small and medium-sized versions. But the large versions of both designs required far more effort, and participants complained that they didn't provide good overview. So there's something going on regarding the ability to focus on the entire object and to focus and refocus on different details. That is, the accommodation of the eyes and moving one's head that might be required. So there's a caveat for the design of large-scale designs that if this is important, they need to be easy to perceive. Large scale, on the other hand, can be more impressive and have a wow factor, but it hinders easily taking it all in and needs more effort to navigate around. So the legibility and affordances for action are important for user experience and are influenced by scale. So this means with large-scale physicalizations, their scale should actually matter and provide extra value. For instance, being impressive, raising and attracting attention in the first place, or letting viewers experience things in relation to their own body. They can contribute metaphorical meaning through that, influencing interpretation. They could, for instance, engender a visceral experience, like being surrounded and walking through a sea of data items, so you experience its endlessness and magnitude. This is making numbers concrete by having the viewer's body and movement in comparison. All of that means that design and scale are not independent design decisions. Some designs only work best in one scale and should thus be optimized for that, e.g. to be handheld and explored intimately. Thus, a comparative study might not be possible. If each scale has different qualities and design and scale need to be matched up for the best fit. With each, we need to think what affordances for viewing, manipulation, and navigation does the design offer at which scale? Does scale contribute to meaning or help convey it? So maybe our start for this study was a bit naive in comparing different scales, but this is a finding as well. And our insights can guide future research to have a closer look at exploiting scale more purposefully. We suggest investigating trade-offs and design recommendations regarding scale.